Okay, so the next talk will be given by Nikos, and he will introduce VPN technology or solution called Openconnect.
Hello, I'm Nikos Mavrogiannopoulos, and I'm going to talk about Openconnect VPN. I'm recovering from a cold, so bear with me. The talk, I will give first some history. Let's see.
No.
It's from there? Okay, is it better? More? Let's see. Now? I guess it's okay. I will first give some history of Openconnect and a little history of the VPN field. I will provide I will give a list of features, what is there in Openconnect. I will also give some details of the protocol for the ones who are interested, because I find it a nice part of this protocol. And finally, I will give examples of usage of the server. I will show you how it can be used and show you the features in real, let's say. The last part will be, I will show you a slide with our future plans for the project. So first, before going to history, I want to say what is a VPN. I guess most of you know already, but let's be explicit about this. A VPN, at least on this talk, when I talk about a VPN, I will mean about a connection between two different LANs over the internet or over any other network that is untrusted in a way that is secure. Let's say we'll assume that it's a secure VPN. I will not discuss any VPNs that are not supposed to be secure. And another use case of a VPN is through a roaming client, a client who is mobile, and he connects to the home LAN over the internet. Or what is actually being commercialized lately is a client who connects to the internet over a VPN. This is often used by British nationals who wants to watch the BBC by getting a VPN address in the UK when they're traveling abroad, or for people who want to use an IP from a different country than they are currently reside from. So all these use cases cover our VPN definition. Now, going to history. In mid-2000, there were quite a few open source VPN solutions. There were IPsec ones, which were being standardized by IETF. IPsec, there were actually quite many. If you check for Opens one, Freeze one, Libres one, there are quite some many implementations. There is also VPNC, which is IPsec for CISCO routers. And also some custom protocols, like OpenVPN, PPTP by Microsoft. And so we had quite many choices. In the closed source world, there were several solutions advertised as SSL VPNs. Cisco had one, it was called anyconnect SSL VPN. Microsoft had one, it was called SSTP. Juniper had another one. There were quite a few. There was a big division. IPsec was a layer 3 VPN solution, while everything else was layer 7. And even today, some people argue that layer 3 is better, others, layer 7 is better. I will not get into that. I will just say that layer 7 works, and it seems to be used quite widely today. The reason was that, especially in the early days, there was no requirement from intermediate routers other than forwarding the packets they already knew how to forward. Now about the SSL VPNs. What does SSL VPN meant? When a salesman would approach you, by mentioning SSL VPN, he could mean many totally different solutions that in the end meant that you could connect to the VPN using your browser. And technically, it just meant that the VPN channel was being established over HTTPS. That was pretty much all. And another advantage of the HTTPS VPN establishment that actually was pretty new to me when I realized it a few months ago was that you cannot distinguish these VPNs from normal HTTPS traffic. And that was very interesting for people who were living in countries where they had censorship, so they were using this kind of VPNs to avoid censorship. Now, this was about VPNs. If you go to Openconnect history, it started around 2008 by David Woodhouse as a client for CISCO's Openconnect, anyconnect VPN. And as such, it's an SSL VPN. It's on this family of VPNs. And David, what he wanted to address with this client is, among others, he wanted to have a client that is portable to other systems than just 386 that CISCO was providing clients. He wanted to integrate it with his desktop, that is Network Manager, and he wanted to add support for smart cards to use a smart card and TPM keys instead of plain certificate files stored in the file system. Most importantly, he didn't trust the binaries that were given by CISCO. It was just the proprietary applications he would get that needed to run as root. He didn't trust it, and he didn't trust it running as root for so many different operations that the VPN client has to perform. So he designed Openconnect in a way that it doesn't need to run as root at all, except for the allocation of a tuned device. Today, it runs almost on every system that we know. It runs on Linux on all the BSD systems, on Mac OS X. There is a GUI client for Windows, one for Android. I think iPhone is the only thing missing today. The server was started by me a few years later, and the reason was different. I had checked all the SSL VPN solutions, not the SSL VPN, I had checked all the open source VPN solutions we had, and I didn't like the layer 7 solutions that were available. They were custom-made protocols. They were not based on TLS or datagram TLS. And for that purpose, when I saw Openconnect, I found a very nice client for a very nice protocol. So I wrote the server side, which as I said, my reason was to have a standards-compliant VPN solution. And in addition to that, my last point there is I was managing at the time a VPN server, and what I didn't like on the existing solutions was that once a user would log into the VPN server, you would never know about him. You would never know who is logged in, who is logged out. You had no information about that. So I wanted to have a server that would integrate client management into the server, and it will not be something that is supposed to be done externally. Today, this server is available for both Linux and BSD systems. and it's developed mainly for Linux, and actually it uses a lot of Linux-specific features. So if I go to the features, I will first describe the features of the protocol, of the anyconnect protocol. It provides two channels on a session. One is a TCP channel that runs over TLS, and the other is a UDP channel. Why is that? The connection is established first on the TCP channel, where all negotiation and authentication is being done, and later all data are being transported over UDP. That is to avoid TCP over TCP issues. The protocol is designed for zero manual configuration because it simply, in the end, it simplifies a lot. The idea is that the client connects to the server sends all the information for the client to access the network, and that is all. The client doesn't need to do anything more than that. The protocol works with both IPv6 and IPv4 and supports compression. Compression can be a red flag for a security protocol, especially if you apply compression prior to encryption. That could reveal more information to someone only checking the length of the data being transferred. But it was supported in the original protocol. In the Openconnect implementations, we try to mitigate the issues from that, and we disable compression by default. As I said, it's an HTTPS-based protocol, which can also allow for a collocation of the VPN server with the web server. And as authentication methods, it allows password and public keys. A user can log in using a password, username and password, or a certificate and a key.
Sorry, may I ask about the last part? Is it possible to use two-way, both of them at the same time?
Yes. You can also use multiple passwords or one fixed password and one-time password. You can do many combinations. Any combination is allowed by the protocol, but I will talk about this in a further slide. You can ask me again if you think it's not covered. Now, if you go to the client, the Openconnect client, as I said, the protocol is designed for no manual configuration, so also the client is designed for no manual configuration. It's integrated in all network managers actually we have in Linux. You can use a smart card with it, or the keys in your TPM chip. As I said, it doesn't require root access to operate, and it supports the LZS compression that is available in the standard protocol, as well as we extended it with the LZ4. And we do it in a stateless way to avoid any attacks due to compression. We're also extending the protocol with the VPN protocol by adding support for TLS 1.2, as well datagram TLS 1.2, and modern ciphers like AES in GCM mode. On the server side, we have password authentication supported either by a password file, a PAM, or even radius. We can set resource limits per client or per groups of clients. It's designed in a way that processing scales with the number of CPUs, so the more CPUs you have, the more users you can handle. Actually, that would be something that you would expect for any software, but it was not really true on any other open source, in most other open source VPN solutions. It supports also the compression options available in Openconnect client, as well as the protocol options. And as I mentioned, it supports online user management. Something I would like to stay on is that the server, I'm sorry, that the server, it was designed to provide privilege separation between the main process and any client worker processes. I will not get into details, but we isolated the worker process using secomp and also the security module which handles PAM and radius as well as the server keys in a way so if there is an exploit on the TLS layer or on any client handling layer, the server keys will remain safe. That is, a heartbeat will not reveal anything to the client that he shouldn't access. So, if we get now into the protocol, the command to open connection to a session to a VPN server is Openconnect and the server name. What happens there? The client connects and sends a post request. A post request which contains an XML configuration for the client that simply mentions its version and also a device ID, which is a legacy from CISCO configuration. The server then replies with the following form, which actually asks the client for its username. The client has to reply, and that goes on until the server believes the client is authenticated. So the server may ask a password, may ask a second password, may ask a group name or anything it needs to authenticate the user. After that, after the server thinks the user is authenticated, the client issues a connect request. You can see there. Sends its MTU as well as the type of addresses it needs to access. It can access. And the server replies. If it agrees, it says you are connected. Here is your address. Here is your netmask, your DNS, the routes that you have, and the MTU is there. There are no IPv6 here to simplify the listing, but it works with IPv6 as well. And that is pretty much the VPN protocol, the authentication part of the VPN protocol. It's pretty simple.
Can you go back to the first slide for a second?
Yep, that one.
Is there any way to do Spinago on top of this?
To what?
Is there any way to do Spinago on top of this?
It depends whether the client or the server would support it. Okay. And this was the way for the client and the server to establish the datagram, the TLS channel. There is a datagram TLS channel that is established after that, and that I didn't get into how it's being established, but you can believe me, it does. And now I move forward to client setup. How to set up a client? Actually, that's the simplest part of the Openconnect protocol, because you don't really need to do anything. You run Openconnect with a server name. You enter your username, you enter your password, and you get connected. All the routes, all the DNS settings are applied, and you can start using the VPN in your system immediately. So, because I have no more to show on this, I'll show you how you can do it on Android. After you select the server, you get a form that is actually the forms that you get from the server. You fill in your group, your username, your password, and you're connected. But because it's made for zero configuration, it means all configuration is done on the server. So what do we need to do for the server to work? A server needs a certificate pair, a key and certificate pair, because it's an HTTPS server in reality. It must have a certificate to authenticate itself to the client. This command to generate a key and a certificate, and after you run it, you get something like that. That would be, you can either have a CA sign your certificate, or most of the times you don't care because you can simply identify, here I don't have an identifier, but you can identify the certificate with either its hash or the ID, the key ID, and you can simply distribute the key ID to the clients, to the users. So what is the most important part is to actually edit the configuration file. And the configuration file of the VPN server is like that. I don't know how visible it is, but what you can do there is that's simply a page of the configuration file. You set the authentication method. You set whether you want to use the worker isolation thing, because it relies on seccomp, and seccomp is not really portable if you have some MIPS platform or PowerPC. You set the maximum. You can set the maximum number of clients, whether the server is on a dynamic DNS, and several other options that relate to VPN operation. After that, let's say you want to create a local password file holding the users. There is a tool called Openconnect password that you can set. You can add users to it with it. And on this example, we add the user test, and we set the password for it. And that's pretty much all. After that, the server should be able to run. And as I said, Openconnect server provides a way to administer the server while it's running. For that, we provide an Openconnect control tool, which administers the server. And as it is now, you can mostly you can view information about the server. You can, let's say, show the status of the server, show the existing users who are connected, show information about specific user or specific connection ID, and as actions that you can, other than view, you can disconnect a user or a specific ID, and you can reload the server so far. If you think that you have some interesting idea, you can just contact me to add to this list. And let's show some example. Let's say we have a running server, and we ask it to show the connected users. This is the command, show users. And we get the two connected users, which is actually me on my system. And we can see that we see an ID, a username, a group name, the IP the user connected from, the device it was assigned to him, and the cipher it's using, and the status. The status can be connected or authenticating. We can also request more information about a specific ID. In this particular case, we get one of the existing ones. And in addition to what we saw before, here you can see also the agent that the user is using, the client, how much data he has transferred already, what is the average bandwidth he's consuming, when he connected, and also the settings that were applied to him. something that's pretty important when you are debugging a remote client. So that's pretty much all about the tool. Yeah.
Does Openconnect supports suspense resume line, like you are closing laptop, moving around, open it, and should you enter password, or it's like some like number of sessions for some time with timeout?
It keeps a cookie, and it can use it to reconnect to the server.
Without password? Re-enter password?
Without password. Yeah. The cookie has a time validity. After it expires, you cannot use it again, but you can resume a session.
And we can set the time for cookie?
Yes, on the server side.
What about floating IP? You suspend your computer, go to the network, open your computer with a new public IP.
That you can configure on the server whether you allow it. Yeah.
Does OSC control use DBus to connect to OSC server?
I implemented it using DBus, but then I changed it to just Unix sockets. And libdbus is hell to use. And because I was using seccomp, in libdbus you don't know what is happening, which system calls are being called underneath. So the code is inactive now. So a feature that was actually asked a lot when I initially made available the server was how to make the server collocate the server with the web server, how to make Openconnect run on the same port with Apache or LightHPD or any other such server. Currently, there are two approaches. One is via SNI proxy or high availability proxy. And this works like that. They take the first packet from the TLS connection, which contains the name of the server. And then if you have your VPN server at vpnexample.com and your web server at webexample.com, SNI proxy will redirect the full TCP connection to the appropriate server, either to Apache or to Openconnect. This means, of course, that you have an overhead. I will talk about this later. Let's see the other solution. The other solution is by having the web server forward the traffic of the VPN to Openconnect. That means that the HTTPS channel is done on the web server, and the web server, for some specific URLs, will forward the traffic to Openconnect server. The problem is that because Openconnect server doesn't get the HTTPS connection, it cannot verify any certificate from the client. That means you can only use this with password authentication. Both of these approaches incur an overhead.
May I authenticate the user by certificating on the server side, like I know HI proxy or NI or something like that? And,
Yes, but the problem is how would you let Openconnect know about this? Yes, I didn't want to get into this because then you can have the client forging a header and we're going to have another class of problems. I'm thinking to solve this in a different way by simply having the server pass the socket, but this is not implemented yet. But yes, it could be done, but you have to use some out-of-band communication that it's not standardized in Linux yet. We don't have that. Sorry, too? Yeah, through PAM. Yes. Both these options incur an overhead because either the web server or SNI proxy has to forward packets all the time, the TCP connection at least from one process to another. So for high volume sites, that is not really recommended. Although the datagram TLS channel remains under full control of Openconnect, so this cost is a bit mitigated if all the clients use datagram TLS, because the client may select not to use it. So now we are on the last slide. This is the future plans of Openconnect. I know David is working on adding Juniper SSL VPN support to Openconnect, so it could connect in a bigger variety of systems. On the server, I'm working on reducing the cost of collocation. And we really want to standardize this protocol. We want to simplify the existing protocol by CISCO, and if possible, collaborating with them to standardize it. So we would like to push towards that. Okay, that's the final. Yes? I use a library, GNU TLS. Yeah?
In CISCO try to prevent the server?
Sorry?
In CISCO try to prevent the server, the anyconnect server?
Yeah, if they tried to prevent the client from connecting there.
No, not the client, but if they try to attack your project or something like that. Say like, yeah, we can do the OCS server.
No. We have no communication with CISCO.
What about other authentication methods? Well, Espinigo was mentioned. What about Kerberos with
Kerberos just use Espinigo.
yeah.
But how would you use Kerberos in a VPN to establish a VPN channel?
The ideal situation here would be actually, I'm the author of a program called KDC Proxy, which will allow you to proxy Kerberos requests over HTTP. So the sort of ideal situation would be that the Openconnect server would support the ability to proxy packets to the KDC. You could obtain a KDC ticket and then use Espinigo to complete the authentication. And so at the end of a single authentication, you have a Kerberos ticket, which you can use for all internal services, and you have used that ticket to do mutual authentication across the connection.
Okay, and you said this is done in a library. Is there a library for that?
Well, the proxy part is done in a library, but it will be very simple to implement. The whole proxy is 300 lines of code in Python. So.
Okay.
You also have the IA Curve extension, which actually allows you to get the 3 tickets overnight. And then one single connection, of course.
Yeah, I'm also exploring a way to actually put JSON API directly into TLS.
Yeah.
That's pretty interesting, but no one has actually asked for it. That's why it's not there. But it sounds like a nice thing if you can combine Kerberos authentication and you get a ticket also while you're in the VPN.
For the enterprise use case, the first thing a user does is log into their laptop. The second thing they do is connect to the VPN. The
Yeah.
third thing they do is
Get a ticket. Yes.
What the ideal scenario would be is that they log into their laptop, that's validated over the VPN, they immediately already have a VPN connection and have a valid Kerberos ticket for the session.
Oh, that sounds pretty. I will. If you can send me more information, I will be very grateful. Yeah. If there are no other questions, I think this ends the session. Yeah. Thank you very much.